Okay, so today we're going to look at graphing these absolute values. So this is considered the vertex form of an absolute value function, and yesterday we talked about what each part of this equation means. So we figured out that the h told us to shift left or right. We figured out that a would either make it skinnier, wider, which would be shrink or stretch, so skinnier, wider. We also figured out that based on if it's positive or negative, our graph would either open up or open down. And then lastly, this K out here told us to either shift up or shift down. So the shape of all of these graphs will always be a V. It might just look differently. So remember that the original one looked like this, and then the rest were just moving around the graph. And so here's a bunch of different examples down here of what these functions might look like. So the graph of f of x equals absolute value of x. F of x is just a fancy way to write y. It's literally the exact same thing. The absolute value graph, the original one, looked just like this graph here. A couple important words you need to know are vertex. So the vertex is this point here. And then line of symmetry is this line that we can draw in that cuts the graph directly in half, and it looks the same on both sides. So line of symmetry. The graph to the right over here is the absolute value of negative x, and if you look, it's the same graph, it's just upside down. So we did some of these yesterday to describe what was going to happen. So I'll do the first one with you. If we look here, out in front we have a positive 2. So that means since it's positive, it's opening up. So we would pick G. The 2 is greater than 1. Greater than 1 means it gets skinnier. Moving on, I see this plus 3. Remember, inside the absolute value symbol, it always does the opposite. So typically we think plus would mean right, but in this case it really means left. And then lastly, we have this minus 5, and minus 5 would mean shift down. For this one. So for this one, out in front, we have a positive 0.5. I saw a lot of people forget you're always going to choose open up or open down. So this one's positive, it's opening up. The 0.5 is less than 1. That means it gets wider. So I saw a lot of people say that. And then lastly, this plus 1 is inside of those absolute value symbols, so it's going to be left. So for this one, we're kind of going to do the same thing, and we're going to use that information to figure out which one of the graphs would best represent the equation that's given. So if you look here and you kind of go through doing the same thing we were just doing, this thing is going to shift left. It's going to shift left 3 if we want to be more specific. And it's going to shift down 4. So starting off, the graph of absolute value of x, the vertex is always starting at 0, 0. So you kind of just want to put your pencil at 0, 0. And then you want to say, okay, this needs to go left 3. Okay, well, this one did not go left 3, so it can't be A. If I do the same thing, it needs to go left 3. Looks like it did. And then down 4. So this seems like it might be a good choice, but you might want to just double check the rest. So again, you're going to start at 0, 0, left 3, but then it's supposed to go down and it goes up. So it can't be that one. And then this one does not even go left, so B would be the best choice. So this is just another example, really similar to the last one. Right away, you should be able to eliminate two of these options because this -2 out in front means that the graph should open down. So right away, you know it can't be A and it can't be B because those both open up. Since 2 is greater than 1, we know that this is going to get skinnier. This -1 here means it's shifting 1 right. And this +3 means it's going to go up 3. So we're going to use that information to look at C and D and figure out which one would be the correct answer. So you're starting at 0, 0. This should go right 1, up 3. So it seems like it's going to be this one. If you look at D, it goes to the left, so it can't be D. Now, if you're going to graph these, this is what you would do. It says put your pencil at 0, 0. Identify H and K because that will move your vertex left, right, up, and down. So just like I was doing on the last few examples, I started at 0, 0, and then I moved left and right and up and down. After you have put your vertex down, you want to draw in the line of symmetry, and then you're going to look at the sign in front of A to figure out if it opens up or down. And then A is going to be your slope. So you're going to count and add some more points, and then you're just going to mirror those points over the line of symmetry because it's always the same on both sides. So I'll show you exactly what all that looks like. So here's your first equation. So we have 1/4 absolute value of x minus 2. So we want to start by looking at which way does it move? Does it move right, left? Does it move up, down? So always start with that first. So if we look at this one, it does not move right and left, but it does move down 2. So we're going to start by putting our pencil at 0, 0, and then we're just going to go down 2. So here's my vertex. And then you're supposed to draw in a line of symmetry. So all you're going to do is put in a dotted line that goes straight through the vertex. So I just made mine red and dotted. The next thing those directions told me was to look at the A. Remember, A is always out here in front. It's positive, so it's going to open up. And then this is actually our slope. So we're going to use it to count. So I'm going to start on my vertex. I'm going to count up 1, right 4. Put a point. And then one more time, up 1, right 4. The graph just has to look the exact same on the other side. So I'm just going to kind of count over. So this is 1, 2, 3, 4. 1, 2, 3, 4. So I would have a point here. And I'm going to erase these. And then it's kind of the same thing. You're just kind of counting over. So 1, 2, 3. This one's 8. 1, 2, 3, 4, 5, 6, 7, 8. And then if you drew in these lines, which that was not a very straight line, it should just look the exact same on both sides. So first thing I want to do is I want to figure out, did it move left, right, or up, down, or both? So if I look at this, I can see right here, this is going to move to the right 4. So you're going to start at 0, 0, and then move however it tells you to move. So right 4, 1, 2, 3, 4. Draw in your vertex. Then you want to draw in your line of symmetry, which is just that dotted line that goes right through the vertex. And then next you're going to look at your A, so that's out here. It's technically -1. Since it's negative, that means open down. You're going to use it to count your slope. So if it's -1, it's technically -1 over 1. So from my vertex, I'm going to go down 1, right 1. Down 1, right 1. And then I just want to make it look the exact same on the other side, which would be like this. And then you're just drawing your line through those points. So again, you want to start off by figuring out, does it move left, right, up, down? So you figure that out by looking here and here. So this one is moving left 2 and up 4. So you start your pencil at 0, 0, and then you do whatever the directions tell you to do. So left 2, up 1, 2, 3, 4. So here's your vertex. And then you draw your dotted line through the vertex. The next thing you do is you look at your A, which is whatever's out in front. Since this A is positive, it's going to open up. The A is your slope, and so it's technically 2 over 1. So I'm going to start at my vertex, and I'm going to count up 2, right 1, up 2, right 1. And then you just want to make it match on the other side. So here is your graph.